Welcome to module 6.6 and we do the project 7 demo. Before that I will show you the code for the VM virtual machine translator that we will see very quickly before we go on to the next stages. So, the very simple code. So I just take in a file and then through this, so I will start with the main. I will take in a file. I have this int argc argv which we need. The input file is taken through argv and that input file, whatever star.vm, the output file will be star.asm. So I just do a single pass here. So this is this main routine while f getters. I read line by line and I initialize my variables. First I do one scan till I reach my first character. So this particular thing is I remove all the white spaces that are before the first character. So in the particular line which I have read into the next command buffer, right, as in the case of your assembly, I just go through till I get the first character, and if the first character is not /n, it is not a new line, I have not put in, or the first character is not a comment, right, then I keep taking this next command into a passed command with till I reach the end of that line. So at the end of this particular while loop, as you see here, at the end of this first while loop, as you see here, I have removed lines that have comments. If there are comments after a particular command, if I have comments, that also I have removed, and now I have a passed command with the first character. All the spaces before the first character are also removed in that line, and any comments in the end of the line or the start of the line is completely removed. Now I have the passed command here. Now from this passed command, I extract the three symbols, namely symbol 1, symbol 2, symbol 3. So while pass command I is not equal to blank or not t or next command, I just parse symbol 1, right, symbol 1. So symbol 1 there will be some white space, then symbol 2, then white space, then symbol 3. So this will extract the first symbol, then from that point I will extract the second symbol, and from that point I will also extract the third symbol. So at the end of this I have extracted three symbols from this, and then now I if there is a symbol at all, symbol 1 is 0 or not, then I generate this code. I generate code for that particular one. So I give the output file as an input. This is a function called generate code, to which I give an output file, and I also give the three symbols, symbol 1, symbol 2, symbol 3 in each line. And this is the A label. Please note that I am passing it through reference. A label is the label that I want to generate, unique labels that are necessary for us to generate in the case of the jump instructions. Then line number I use because don't forget that we need to have diagnosis. Always we need to have diagnosis. So if there is something wrong, we need to print the line number where that thing. And I also have a symbol 4. The symbol 4 is nothing but, for the static variable I need this is a temporary. For static variable I have to put, as you said, it is xxx dot index, right, that xxx, that first part of my file name. Suppose I am saying some add.vm, that add should go in as symbol 4. This is for generating the labels for the static variables, as we had discussed. Now the next thing is generate code. Generate code is a simple routine here. Yeah, generate code. So I take the first symbol, I just compare it whether it is push pop. If it is not push pop, then it is certainly arithmetic. Then if it is add, I put the code for add. If it is subtract, I put the code for subtract. And or neg not eq. See, note I am using this a label and I am incrementing it by 2, eq and then greater than, less than. Else this is going to be memory access, so I put push. If it is push, then this part of the code will give me the push. So one of the thing is, when it is push, I use the symbol 2 to basically get the I use the symbol 2 to get the get segment. So if it is argument, then I will return arg, LCL this that, and if it is pointer, I need to return 3 and I return 5. This is the segment code for the different segments. But if it is constant, I have to return that index itself. So I also take symbol 3 as an input to this. And if it is static, please note that if it is static, I string cat the file name, it is come here as symbol 4 along with your symbol 3, which is the index. So symbol 1 will be, in the case of push command, symbol 1 will be push, symbol 2 will be segment, symbol 3 will be index, right, the 3 symbols. So this file name dot that index will come. So this is what we do that in the case of static. And then in the case of push, we do, this is the code for push, this is the code for pop, and in the code for pop, note that if your symbol 2 is a constant, then it gives you an error stating the line number. So this will help you to debug if you had a wrong VM code. And so this basically is the code for pop, and that is as per description as we had seen in the past. Okay. So this is what we have done, and let us now go and so to this code we actually give the input, and we will see the generated outputs. This is the input VM file. And this is the this is the VM file that has been ASM file that has been created. Sorry. So this is push constant 17. So as you see here, push constant 17, this is the code for push constant 17. This is a code for EQ. Then this is a code for again push constant 17, push constant 16, and so on. So, we will also see something on memory access. So, this is the VM file. And this is the ASM file. And you can see all this. Okay. So, now we will now go and show some execution here. Sorry. So, how do we do this execution? Now, we go to this NAND to Tetris. We look at this 7, we look at the tools, we open the CPU emulator, on the CPU emulator we can load this files. I will just show you loading of one of these files. So, I have loaded this simple add. Now, you can also load the script for that simple add. There is a simple add.tst script. You can load that and then we can run it. Just run that. So, we will run it completely, make the simulation faster also. Says it compares. So, you need to load the script for each ASM file and then it will. So, we can also do one more just to make your. So, we can write the script, load the script for, we did for simple add. Now, let us go for stack test, load the script here. Now, run this. Right. Okay. So, comparison ended successfully. So, this is how we do this project and complete. So, this is the code. So, hope we will do project 7 very quickly. As you see, it is a very simple project. So, any doubts, please do put on the discussion forum and we can discuss it further. So, now we move on to module 7 in the next session, and that is going to be a very interesting module, where we are now going to talk of the next two functions, namely the program flow function and the program flow instructions and the function call instructions, and that will make our virtual machine complete. So before we go there, I want you to get a full understanding of this particular, how this translation of memory and stack arithmetic instructions work, and that will make life much easier for you there, right. So, please spend that quality time and get this working. All the best. Thank you.